I don't know what's going on with this background. It's a little fuzzy, but hopefully you can see me clearly and can hear me clearly. We are going to focus today, 7th graders, on algebra and word problems, how we set them up and how we solve them and how we break it down. And hopefully these aren't quite as scary for you at the end of this lecture as they are for many people in real life. So let's get to it. We're going to work 3 problems. We're going to break them down. We're going to see what we can learn together. So let's start off and let's talk about, there's 3 types of word problems that we're going to do today. So these are just 3 examples, and it doesn't teach you how to do every problem in the world, but it does give you, we are going to talk about a methodology, a methodology for solving various word problems. All right. So the first type of problem, this is going to be, I'll talk about this word problem, and I'll talk about ones that are like it, and then it'll give you a whole class of word problems that you can solve. But this is going to be the quote, the age of the age of sisters problem. And this is very generalizable to all kinds of things, like the sum of 2 numbers. It could be, the age of 2 people. It could be the amount of money in 2 pockets. There's all kinds of versions of this problem. But the way that you might see it is you might see 2 sisters were born 5 years apart. So that'd be like information number 1, and then the sum of their ages is 43. Now you can try. There's a couple ways to do this. To solve, you can do, check and not check and guess. It's guess plus check, and that's valid. I mean, this is an okay method, but not precise, but not the best mathematically. And the reason is because when numbers get big or are decimals, this method doesn't work well. It's simply hard. But this is okay. You can actually you could solve this with guess and check, but we're not going to do that. We're going to do this algebraically. And the way that we need to do that is, we're going to, step 1, we are going to set up expressions for the ages of both sisters. And 2, we're going to then write an equation. And then finally, we're going to solve. Well, not finally, we're going to solve, and then 4, we're going to check our answer. Okay, so we're gonna leave off this guess and check thing, and we're going to stick with this method right here. Okay, let's get into solving mode. Let's go back to a kind of a bluish color here. And so if 2 sisters are born 5 years apart, do I know, you need to ask yourself, do I know how old either one of them are? And the answer is no, I don't. So let's call one girl the younger sister, and we're going to call the other one the older sister. And we're going to, we're not talking about their names, we're talking about their age. So let's just say, I don't know what the younger sister, I don't know what either one of them are. So how old either one of them are. So let's just call the younger sister, what can we call a number in algebra when we don't know the value? That's where we use a variable. And we in math always seem to like this variable x. So if one person is x, one sister's age is x, and two sisters are born 5 years apart, the older one is how many years older than the other one? I want you to answer that for yourself. Think about it. And you're going to come to the answer, hopefully, that they're 5 years older. So the older daughter is 5 years older than the younger daughter. So if the younger sister is x, so let's just pretend x is, say, 6, the older sister would be 11. So that would be whatever the younger sister is, plus 5 is how old the older sister must be. And so this is the whole key to every problem we're going to solve today, and every problem that you're going to solve that's going to be like the age of sisters problem. You're going to find you're going to declare one age to be a variable, and then you're going to figure out, well, if that person is this old, then the other person is this amount older or younger, based on an expression. So now what we have is two expressions that represent their two ages. So if now I've kind of used this piece of information and I've set up an expression for the ages of both sisters, now I need to write an equation. Well, what do we know in part 2? Well, the sum of their ages is 43. What does the sum mean? That means you add. Sum means add. So the younger sister's age plus the older sister's age, and I'll put that in parentheses, equals 43. So that's step 2. So this was step 1. This is step 2, write an equation. Now that we have an equation, we can solve it. We can solve this equation by simplifying both sides. We know that we have two values of x over here, or two instances of x. And because this is a positive sign, a plus sign, we can just remove our parentheses. X plus 5 equals 43. And now we can combine our like terms because we have two instances of x. So an x plus another x is equal to 2x. So that's 2x plus 5 equals 43. Now remember from the lesson that we had in class or how to solve these problems, what we do to our x, we have to kind of undo it. So we kind of multiply by 2 and add 5, and if we multiply by 2 and then we add 5, right? X times 2 plus 5. To undo it, we need to go in the other direction. We need to subtract 5, and then divide by 2. So, right, this is what we're going to need, the strategy we're going to need to utilize in reverse order, right? Reverse order from what we did to the x in the first place. So let's start with our subtracting 5 from both sides, minus 5, and we get 2x equals 38. Now we've subbed 5 from both sides. Now we need to divide both sides by 2. And I'll put the answer over here, and we get x equals, well, 38 divided by 2 is 19. So are we done? And the answer is no, and especially because we're doing a word problem, we are not done. We have to do a number of things. We have to answer the question, how old are the sisters? Well, I know that x is 19, so my younger sister, 19 equals age of younger sister, And our older sister is x plus 5. So 19 plus 5 equals 24 equals age of older sister. And we can actually, just really call out, we can kind of box inside the box our two answers if we really want to be really explicit for Mr. Lipscomb. And so let's check our answer. Now, when we check our answer, we can plug them into the equation, or we can look right back at the original problem and say, well, two sisters were born 5 years apart. Does this work? Is 19 and 24 5 years apart? Yes. They're 5 years apart. We'll call this our check. And the sum of their ages is 43. Does 19 plus 24, 3, carrier 1, 4. Yes, and then the sum is 43. Check. So we are done. We have solved the problem. And so when we solve our problems, we go, happy cat. We got a happy cat. We've solved this problem. So this is the age of sisters problem. Now, let me just say that there's a couple other problems that you might see that's like this problem. One of them will be the, you might see, two numbers are, let's try it like this. Two consecutive numbers have a sum of 33. What are the numbers? That is a similar problem because you end up with two numbers. You're going to end up with expressions that look like this. Because what you're going to say is you're going to say, well, I don't know what either of the numbers are. So let's say that, here, we'll put it right here, that the first number is x. X is the first number. And if two numbers are consecutive, then that means they are 1 apart. So what expression would represent a consecutive number that comes right after a number x? Think about it. Well, it would be x plus 1 equals the second number. So x and x plus 1 represent two numbers that are 1 apart. And so that would be our step 2. Our step 1. That's our step 1. And our step 2 is write in an equation. So we end up with x plus 1 equals 33. And now you can see that this problem is exactly like this problem. And we can go about solving this problem. And when you solve this problem, I'll just cut to the chase. Should you want to experiment with it and try it out, you'll get the numbers 16 and 17 will be your answers. Okay, that's problem type number 1. Hopefully this was helpful. We did solve the problem. We got our happy cat. We are going to now go on and create problem type number 2. In problem type number 2 is going to be the picture spacing problem. So this is a picture spacing problem. And we did one of these in 7M3. Whoops. 7M3 lesson 7. But we're gonna try it again. So the idea here is you have this wall. And the whole key here, let me tell you a little bit about this this problem. The whole key is going to be, 1, to draw a picture. This is our methodology for solving. Draw a picture. And then number 2, we're going to write expression. Write 2 expressions. And then 3, we're going to create an equation, we're really just going to write one expression. It's going to be obvious what the second expression is. So we'll just say write an expression. Then we're going to create an expression. Then we're going to solve, and then we're going to check. Okay. This picture spacing problem works like this. It's like I have two. We'll write it in this color. So I have two pictures to hang on a wall. The pictures are the same size. I want an equal amount of space between the wall and each picture, and between each picture. So let's just break that down. So I have to start, let me start by drawing a picture. So this will be step one. So we're going to draw a picture of this wall. Whoops. Oh my goodness. Picture of the wall. What? Come on. Okay, so there's our wall. And now I want to put my pictures in this wall, and I want to let me just draw it like this. So we got to kind of make the pictures the same size, and so the idea is that these pictures are the same width, and the picture, we'll say the pictures are 2 feet wide, and the wall is 19 feet wide. Question is where do I put the pictures? So let's do some labeling of what we know. That's what this is going to be step one. Draw the picture. So we've drawn the picture. Now we know that this whole thing, this whole distance from here to here, we know that's 19 feet. And we know that this distance here is 2 feet. And this one likewise is 2 feet. So the question is, if I look at this distance, how far are these green distances? And what the problem has said is that the green distances are all the same amount. And I don't know, so I don't know what this amount is. And what do we use when we don't know an amount in a word problem? We say, well, that's X. And because they're the same, it's not bigger, it's not smaller, it's exactly the same size, I'm going to say that all of those are X. Okay, so I can now I've written my, well, I can say, I'm going to label it, I'm going to say, well, X is the distance, between pictures and between wall and picture. Okay, so X is that distance. So let's look at, we've written the expression, we've described it. So let's write an expression that describes how far it is from here to here. Well, if it's X plus 2 plus X plus 2 plus X, that's how far it is from If I go all the way from here to here, that's x plus 2 plus x plus 2 plus x. So let's write that. X plus 2 plus x plus 2 plus x. And that whole distance is equal to 19 feet. So there's two ways to get there. One, I can just say, well, I know the wall is 19 feet. And the other thing is, well, it's this magic distance here, plus this distance I know, plus this magic distance, plus this one I know, plus this magic distance. Now we have an equation. Now we've drawn our picture, we've written an expression, we use that expression here to set it equal to 19 to create our equation. Now we're on the solve part. And what do we do? What do you notice? Take a chance to pause. And what do you notice about solving this problem? Pause. Okay, now I'm going to assume that you paused the video and you've noticed that it's time to combine like terms. We have an x, we have an x, we have an x, and then here we have plus 2, and then plus 2. So let's combine our x's. So we have our x plus x is 3x, plus 2, that's plus 4, equals 19. Now what we have is a two-step problem. Some of you have learned how to solve these quick and in a more expedient fashion, but let's stick with the long approach. Let's look at what we do to our x to get to our 19. We first multiply by 3, and then we add 4. And we need to figure out how to undo that. And we undo in the opposite order. So we undo it adding 4 by subtracting 4. And then the second thing we do is we divide by 3, which undoes multiplying by 3. So we're going to look at our list of things to do. We're going to subtract 4. Make this easier to read. Subtract 4. And so I get 3x. These cancel, equals 19 minus 4 is 15. Now we need to divide by 3. And we get x equals 5. 5 feet. And so we think that's the distance between our pictures, but let's check our answer. If we say, well, this is 5, and this is 5, and this is 5. Well, does 5 plus 2 plus 5 plus 2 plus 5, does that equal 19? Well, here's, 7 plus 5 is 12. So let's say 12 plus 2 plus 5. 12 plus 2 is 14 plus 5. 14 and 5 is 19 equals 19. So check, it does work. So the answer is we need to put our pictures 5 feet apart and 5 feet from the wall. And then if we do that, we get our happy cat. We've solved the problem. Now, I know I told you that we were going to do 3 word problems in this lesson. I think we're going to just stop it at 2 word problems. I might do more later on, but we're going to let that be good for now. We've learned our methodology. Sometimes we have to draw pictures, but the idea is write our expressions, write our equations, solve our equations, check our answer. Again, may have to draw a picture to help us build our expressions in some cases. Hopefully this was helpful. Wow. Oh, gotta go get the door. I'm out of here. See ya. Bye.